Question number 33 in your quadratic for quadratic functions asks you to convert the following equation to intercept form. So this means that we're going to have to factor this equation. So first what I'm going to do is bring out a 1/4 from every term here. So we have 1/4 times x minus 6 squared minus 71. Then I'm going to distribute or multiply out this x minus 6 squared. So I'll have 1/4 times, I'll make these brackets to make it a little clearer. So we have x squared minus 12x plus 36 minus 71. Then we have 1/4 x squared minus 12x minus 35. And so in order to factor this, we'd be looking for something that multiplies to negative 35 but adds to negative 12. It's very hard to see, but in any case that we would have, so factors of a negative 35 would be negative 5 and 7, negative 7 and 5, like negative 1 and 35, 1 and negative 35. None of these add to negative 12, so we can certainly say that this is not factorable, and we can actually sort of prove that it's not factorable if we try to find the x values or the zeros for this function inside the parentheses. So if we use the quadratic formula for this, we would have x times negative 12 plus or minus square root of 12 squared, or negative 12 squared, so that'd be 144 minus 4 times 8 times c, which would be, I'm just doing it quickly, so we would get something inside the parentheses that equals 144 plus 140, so that'd be the square root of 284 over 2a, which is just 2. So that square root of 284 doesn't come out to be a rational number. Or it is rational, but it's not an integer number. So in order to factor that, we'd have to come up with some crazy factorization, like using square roots and radicals in our answer. So it's, for all our purposes, it's not factorable.